You've been lied to. Chemistry is not 118 elements and 1,000 rules you have to memorize. You, on a Sunday, sliding off the couch onto the floor. Not because the floor is nice, but because the floor was closer and you could stop trying. That's it. That's the whole universe. Everything in it is exactly this lazy. Meet SLUMP. SLUMP is every atom in existence. SLUMP has one personality trait. He wants to do the least possible. He cannot stand up. He will not stand up. He rolls downhill and stops. And here's the part that should bother you. You are made of 7 octillion of him. 7, followed by 27 zeros. 7 billion 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 little quitters. So here's the game. One lazy rule walks into the ring. Every big idea in chemistry lines up to beat it. And you get to watch every single one of them lose. Challenger 1, the atom itself. A clump in the middle, protons, neutrons. And the proton count is the atom's whole identity. 1 proton, hydrogen. 79, congratulations, you're gold. Around that clump, electrons. Not orbiting in neat little rings, that planet picture is a cartoon we keep drawing because it's easy. They're really a fuzzy cloud of probably somewhere around here. The nerds call it an orbital. The electrons fill up in rows, and here's the only part that runs the entire show, the outermost row. The passengers on the edge. Everything an atom does, every reaction in your body, comes down to those outer electrons. Those outer ones have a name, valence electrons. That's it. That's the atom. Round 1, done. First proof the lazy rule holds. An atom's entire behavior is decided by its laziest outermost passengers. And the famous table? It's just a seating chart. One column lights up. Everybody in it has the same number of outer passengers, so they act alike. Left side, the shiny metals. Right side, the non-metals. And a little diagonal staircase of in-betweeners cutting down the middle. It's not a chart of facts to memorize, it's a chart of who acts how. Challenger 2, bonding. Why do atoms stick together at all? Same reason as everything, it's downhill. And no, the atom doesn't want a full outer row. It doesn't want anything. A full row just happens to be lower energy, and downhill is downhill. SLUMP keeps me honest. Bonding isn't one thing, it's a slider with 4 settings, and each setting is just a different human relationship. Setting 1, 2 atoms share electrons evenly. A fair marriage. Both pull the same, nobody wins. That's a covalent bond. Setting 2, they share, but one yanks harder, so the electron spends more time on the stronger side. A lopsided marriage. One partner hogs the blanket. How hard an atom yanks on the shared electrons is a thing chemists actually measure. They call it electronegativity. Big word, simple idea. It's just grip strength. Fluorine has the strongest grip of anybody. Fluorine does not do gentle. Grip generally gets stronger toward the top right of the table. Generally, not always. Chemistry hates absolutes. Crank the slider further. One atom rips the electron clean off the other. Now you've got a plus and a minus, and opposites snap together like magnets. A mugging that turns into a clingy relationship. That's an ionic bond. Last setting, a whole crowd of metal atoms throws their outer electrons into one shared pool and just floats in it together. A commune. Everybody owns everything. The nerds call those electrons delocalized. That shared puddle is why metal conducts and bends. And here's the magic trick. Sodium is a metal so violent it explodes in water. Chlorine is a gas that was literally used as a war weapon. Bond them. 2 murderers become dinner. Table salt. The thing on your fries. Not magic. The bonded pair is a completely new thing with its own rules, and its outer electrons are now arranged comfy and low. Round 2. Bonding tried to be complicated. It was just 4 kinds of lazy. Down it goes. Challenger 3. States of matter. Solid, liquid, gas. This one feels obvious, but watch what it actually is. A tug of war between 2 things. How hard the particles cling and how much they're jiggling. When clinging wins, particles lock into place, holding on tight. A solid. Heated up, jiggling gets stronger, the grip loosens, particles start sliding past each other. A liquid. Same particles, looser hold. More heat, the grip lets go entirely. Particles fly off on their own. A gas, and crank it absurdly high, hot enough that the electrons themselves get torn loose. Now it's the atoms themselves coming apart, not just particles letting go of each other. That's plasma. Stars are made of it. Same tug of war, just turned all the way up. Every melt, every boil. It's the comfy rule deciding whether clinging or jiggling gives the particles the lower energy life. Round 3, gone. Challenger 4, reactions. The big scary one. A reaction is just atoms breaking old partnerships and forming new ones to end up, say it with me, comfire and lower. If the new arrangement sits lower than the old one, the leftover energy comes out, usually as heat. That's every fire, every explosion, every warm thing your body does. Stuff falling into a lower comfy spot and shedding the difference. But here's the twist that runs your whole life. Even downhill reactions usually have a tiny hill to climb first. A little bump before the big drop. That bump is called activation energy. It's why paper doesn't burst into flame just sitting there. It's already downhill of ash. It just needs a shove over the bump. That bump is the only reason your house isn't currently on fire. Everything around you is sitting downhill of ash, politely waiting for a shove. You're welcome. And a catalyst? It just digs a shortcut through the bump, a lower path, without getting used up itself. Your body is stuffed with them. They're the only reason you're not running every reaction at the temperature of a campfire. One bit of bookkeeping, fast. Atoms are too small to count, so chemists count them in a unit called a mole, which is just a chemist's word for a truly stupid number, a 6 with 23 zeros after it. About 600 billion trillion. It's a dozen, for people who gave up on small numbers. That's the whole idea. Moving on, round 4, down. Reactions were never magic, just atoms shuffling toward comfy with a speed bump in the way. Wait, stop, because if you've been paying attention, there's a hole in everything I just told you, and it's about to swallow the whole rule. Ice melts in a warm room, but melting absorbs energy. It goes uphill. Cold packs get colder by themselves. Things that should cost energy happen anyway. So the lazy rule should be broken. Here's the blind spot that should have stopped me 10 minutes ago. Every single time I said comfy, I only showed you half of it. And SLUMP knows it. You lied to me. No, I didn't lie. I just hadn't told you comfy's second half. Comfy was never just about being low. It's also about being spread out. Think of a drop of dye in water, or a smell filling a room. Nobody pushes it. It just drifts everywhere, because there are way more ways to be spread out than to be bunched up. Stuff slides toward more spread out for the same reason it slides downhill. It's the lazy direction. A pile of laundry on the floor is way comfier than folded laundry, and the universe agrees. That spread outness has a name, entropy. So real comfy is a two-part deal, low energy and spread out. And which one wins depends on temperature. Melting ice loses a little on the energy side, but it wins so big on the spread out side that the universe takes the deal. The mess payoff beats the energy cost. That tug of war, low energy pulling one way, spread out mess pulling the other, with temperature deciding who wins, is bundled into one idea called Gibbs free energy. You just learned it without a single formula. And some reactions can run backwards too, comfy enough in both directions that they keep flipping. So they settle into the laziest standoff there is. Two crowds shoving through one doorway in opposite directions at the exact same rate. From outside, nothing's changing. It looks finished. Inside, it's chaos both ways, perfectly canceling. We call that equilibrium. So the rule didn't break. It got bigger. Lazy was never just falling down. It was also spreading out, that entropy thing, the whole time. Same lazy guy. Now we can see both his moves. Last round, acids, bases, and the meanest reaction of all. An acid is just something that drops a little charged hydrogen bit onto whatever's nearby. A base is the thing happy to catch it. A hot potato. How eager something is to toss that potato is the pH scale. Low is sour and grabby. High is slippery and soapy. Water sits right in the middle. Chemists named the hot potato idea after two guys, Brunstad and Lowry. You can just call it hot potato, but the meanest reaction in the whole building is redox. And the trick to understanding it is simple. Follow the electron, like following the money. Who's losing one, and who's grabbing it? Rust, fire, and being alive are the same reaction at 3 different speeds. Iron rusting is slow. Fire is fast. And you, right now, breathing. That's the same electron-stealing reaction. Run carefully, on purpose, to keep you warm. Here's the landmine everyone trips on, so I'll say it slow. The thief, the one gaining electrons, is the one chemists call reduced. I know. The robber gets richer, but we say he's reduced. The word's backwards on purpose-ish. Reduced isn't about getting smaller. It's an old bookkeeping word. Gain a negative electron, and your charge number goes down, gets reduced. So hold the picture, not the word. Gaining electrons, reduced. Losing them, oxidized. And the bully doing the mugging? That's the oxidizer, named for what it does to its victim, not to itself. Oxygen is the most relentless mugger in the entire room. Round 5, defeated. Even the scariest chemistry was one lazy electron rolling downhill into a hungrier hand. So that's it. Every challenger, beaten by the same dumb rule. The whole universe has one job. Get comfy, stay comfy, never get up again. Everything is rolling toward lower, more spread out, more bothered by nothing. Stars, oceans, your coffee going cold. All of it, quitting. All of it, downhill. So name one thing in this entire lazy universe that fights downhill. One thing that refuses to spread out, refuses to cool off, refuses to quit. Spotlight's on. It's you. You're it. Being alive is shoving 7 octillion lazy atoms uphill, every second, holding a pattern the universe is constantly trying to dissolve. That isn't poetry. That is the actual chemical definition of being alive. Every breath, every heartbeat is you paying the bill to not be comfy yet. To stay a tense, structured, uphill thing in a universe that just wants you flat. And the day you stop paying it, you spread out, you cool off, you reach equilibrium at last. Comfy, finally. The universe gets its blob back. The rule always wins. Always. You're just the longest it's ever had to wait. And the whole time you've been watching Slump lose, you've been doing the one thing he never could. You stayed up. So before you go, back at the start, 4 ways to bond. The fair share, the blanket hog, the clingy mugging, the everybody owns everything commune. Which bond are you? Tell me in the comments.